Okay, for my last video in this section, I have another example where we have a radical, and then outside of the radical, we have both a variable and a number. First thing that we're going to notice on this one, though, is that our radical is not isolated yet. It's not by itself. That negative x is on the same side of the equation with the radical. So the very first thing we're going to have to do is move that x over to the other side by adding. So that's going to give us square root of 2x minus 5 equal to x minus 2. It's a positive x minus 2. All right. Then just like in number 7, we're going to square both sides. So this comes out nicely to just 2x minus 5 because the root and the exponent cancel. But over here, we're going to have to do a little bit of extra work. We're going to have to square that binomial. So I've got a little work area set up over here, and I'm going to have to make an area model to multiply x minus 2 by x minus 2. That gives me x squared. X times negative 2 is negative 2x. Again here, x times negative 2 is negative 2x. And negative 2 times negative 2 gives me a positive 4. So it's x squared minus 2x minus another 2x plus 4. And I can combine these two, as they're both x terms. So I wind up with x squared minus negative 2, and another negative 2 gives me negative 4x plus 4. Okay, so I have my quadratic equation. I had to do all this side work to get this side of the equation. Now I have a quadratic. With a quadratic, I always want to get a set equal to 0. So I'm going to look for where my quadratic is, and I'm going to move things towards that. So I want to move the 2x over, so subtract 2x from both sides. Now I want to move the negative 5 over, so I'm going to add 5 to both sides. These will cancel. So it's going to give me x squared, negative 4, and another negative 2 gives me negative 6x, and this gives me plus 9. Since this all went away, this is equal to 0. So I'm looking for numbers that will multiply to give me 9 and add to give me negative 6. The only way to get 9 is 1 and 9, or negative 1 and negative 9, and 3 and 3, or negative 3 and negative 3. And the only one of those that's going to add up properly is negative 3 and negative 3. Notice these two are the same. So that's going to affect how many solutions we get. So we get x minus 3 times x minus 3 equals 0. If I take this first x minus 3 and set it equals 0, I'm going to get x equals 3. But here, I'm going to get exactly the same equation and exactly the same solution. So I only have one potential solution. Of course, I don't know yet whether it's a true solution or extraneous. So to do that, I have to check. So I've got my original equation. This time I'm only going to have to check one, though, because I only have one possible solution. 2 times x minus 5 under the radical. And then outside of the radical, minus my x equals negative 2. Notice I'm going back to my very original equation. I'm not doing it after any modifications have been made, because any changes that I made to that original equation might affect whether or not this solution works. So I have to go back to the very beginning. So I plug in my 3 here and here. And then I just simplify it piece by piece. 2 times 3 is 6, minus 5 is 1. So this gives me square root of 1 minus 3 equals negative 2. That's what I'm checking. Square root of 1 is just 1. So 1 minus 3 equals negative 2. Is that a true statement? Yes, it is. So I can go back up to my x equals 3, box that up because it's good.